Hello, I am Avaneesh Shetye and I am going to implement and explain the Boolean logic gates in NAND2Tetris Project 1 and 2. So, what is NAND2Tetris? NAND2Tetris is a 12-part course in fundamental computer engineering that steps you through the creation of a computer from the ground up, starting with NAND logic gates and ending with an operating system capable of running a complicated program like Tetris. Hence the name NAND2Tetris. The course is architected by Noam Nissan and Shimon Shokin. Logic gate. A logic gate is an electronic component that can be used to conduct electricity based on a rule. The output of the gate is the result of applying this rule to one or more inputs. These inputs may be two wires or the output of other logic gates. Logic gates are electronic versions of Boolean logic. Truth tables will tell you what the output will be depending on the inputs. For example, AND, OR, NOT, NAND, NOR, XOR, and etc. Moving on to project 1. NAND gate. A NAND gate is also called as a universal gate, meaning that it can be used to make all the other gates mentioned in the previous slide using nothing but NAND gates. Another example of a universal gate is a NOR gate. This is the symbol and this is its truth table. AND gate. The AND gate is named so because if 0 is called false and 1 is called true, the gate acts in the same way as the logical AND operator. The following illustration and table show the circuit symbol and logic combinations for an AND gate. And this is its representation using NAND gates only. Now I will implement it in the hardware simulator in the NAND2Tetris course. And if we compare the outputs here 0001, 0001, they match. Next, the OR gate. The OR gate gets its name from the fact that it behaves after the fashion of the logical inclusive OR. The output is true if either both of the inputs are true. If both inputs are false, then the output is false. In other words, for the output to be 1, at least one input or the second input must be 1. The symbol, table and representation using NAND gates. And this is its implementation in the simulator. And as we can see, the outputs 0, 1, 1, 1. The output is 0 if either one of the inputs is 1 and 0 if both are 0, which matches with our truth table. NOT gate. A logical inverter, sometimes called a NOT gate to differentiate it from other types of electronic inverter devices, has only one input. It reverses the logic state. If the input is 1, then the output is 0. If the input is 0, then the output is 1. The symbol, table and representation using NAND gates. And in the simulator, as we can see here, input 0 gives output 1, and input 1 gives output 0, which matches the truth table. XOR. The XOR, also called exclusive OR gate, acts in the same way as the logical either or. The output is true if either but not both of the inputs is true, and the output is false if both inputs are false or if both inputs are true. Another way of looking at the circuit is to observe that the output is 1 if the inputs are same, if the inputs are different, and 0 if the inputs are the same. The symbol, table and representation using NAND gates, and this is its implementation in the simulator. We can see here 0110 and 0110. Next, multiplexer. A multiplexer selects an input from several inputs, then it is transmitted in the form of a single line. An alternative name of the multiplexer is MUX or data selector. This is the block diagram, circuit and truth table and the simulator. We can see the output here 0001, 0001, 1011. Next, demultiplexer. It does the opposite of the multiplexer. It uses one input signal and generates many. So it is known as demux or data distributor. Block diagram, circuit and truth table. We can see the output here. Next is the OR 8 way. This takes 8 input and does the OR operation on all of them. This is its circuit. The output. Next, mux 4-way 16. This is the block diagram and truth table. And the output. Next, mux 8-way 16. This is the truth table. This is the output. Next, moving on to project 2, half adder. Half adder is a combinational logic circuit which is designed by connecting one XOR gate and one AND gate. The half adder circuit has two inputs A and B, which add two input digits and generates a carry and a sum. The output obtained from the XOR gate is the sum of the numbers, while that obtained by AND gate is the carry. There will be no forwarding of carry addition because there is no logic gate to process that. Thus, it is called half adder. This is the circuit and truth table and the implementation. We can see there these match. Next, full adder. Full adder is the circuit which consists of two XOR gates, two AND gates, and one OR gate. Full adder is the adder which adds three inputs and produces two outputs, which consists of two XOR gates, two AND gates, and one OR gate. The first two inputs are A and B, and the third input is an input carry as Cin. The output carry is designated as Cout, and the normal output is designated as sum. The equation obtained by XOR gate is the sum of the binary digits, while the output obtained by AND gate is the carry obtained by addition. This is the circuit and truth table, and in the simulator. And we can match these. And that is the end of my presentation. Thank you.